Oops, I didn't hit mute on myself. Okay. Whoa, forgot to. Don't want an infinite loop here. Welcome back to the Coding Fanatic YouTube channel. I'm your host Richard Clark, and here at Coding Fanatic, I am now going to teach Android developers how to build scrollable apps using Jetpack Compose. If that sounds like content that you are interested in, then join the mailing list over at codingfanatic.com. So welcome to the very first Android Architect live stream. Now, if you're a newcomer here, welcome. For the people who've been watching my content for the last few years, you'll notice that tonight's intro is a little different. The reason being is I've decided to focus on a new area of Android development, and that is namely building scrollable apps, namely using Jetpack Compose. Now, the reason I've made this change is because over the last couple of years, Coding Fanatic has been more about helping new Android developers. I was a new Android developer, and I had ideas for apps. I wanted to build them and get them on the Play Store as quickly as possible. So my goal was to take what I learned doing that and reach out to other new developers who are in the same boat and try to take the techniques that I've learned and package it for you. I ran into a lot of people who say, oh, I want to do Android development, but I don't know where to start, or I want to be a software developer, but don't I have to go to school and take a lot of math? No, you do not. So my goal here at Coding Fanatic has been to reach out to those new folks and show them that it's not as difficult as you might think. There will be some challenges along the way, but you can get in if you just follow these simple steps. Well, now that I've been doing that for since the very beginning of Coding Fanatic, I want to try something. I want to do something different now. And the new thing I want to do is I want to focus in on one really important thing, one good thing that I believe will be beneficial, not just for myself, but for you for developers in general. So I've chosen to start building scrollable apps. Most apps we use now, Facebook, Instagram, Amazon Prime, everything, all have some scrollable functionality, right? So the game is now to focus on scrollable apps. But I don't just want to build apps that are scrollable, because you can do that with Java, you can do it with React Native, you can do it with Kotlin. I am specifically choosing to use Jetpack Compose and use Jetpack Compose to build these scrollable apps. My hope is that everything I've learned up till now will help me to get into this to get into it quickly and efficiently. But with software development, you already know how it goes. If you're seasoned enough, you know that hope is irrational, and it doesn't matter how much hope you have. The compiler will yell at you when it wants to. Your computer will yell at you when it wants to. All you can really do is persevere and push through. So, with that being said, yes, I'm focused on building scrollable apps using Jetpack Compose. I don't really know much about Jetpack Compose except for the fact that you can use it it's kind of like Flutter. That's as much as I know. You can use it to build user interfaces, which is pretty cool. But other than that, I've got nothing. I don't know anything about it. So I am coming into this as a newcomer. I'm brand new. I'm just a new save file, and I'm going to show you guys my journey and break down some tips that I would give myself tonight if I could go back in time and say, hey, you guy over there, you're new to Jetpack Compose, here, do this. Make sure you go on, you do these tutorials and do it this way. So anyway, that's the game moving forward. There are 3 areas that I want to focus on in order to really drive home how to build these apps. And I believe these 3 areas are the pillars of Android development in general, or software development in general. These are 3 things that I truly believe are the most important things to focus on, but I am going to shift it specifically for building apps using Jetpack Compose, building scrollable apps using Jetpack Compose. All right, so the first thing I want to focus on is, of course, building apps on your own, taking the time to practice. Practice makes perfect. So you have to put the time in if you want to grow. I've never used Jetpack Compose. I've used Flutter, but I've never used this specific tool. So my game will be to spend more time building apps and writing code using Jetpack Compose so that I can get more acclimated to building these scrollable apps. As far as I know, recycler views are the best way to build a scrollable list, but who knows what, things might change and there might be a more efficient way of doing it soon. So for the time being, I am focused on using Jetpack Compose to build recycler views, which will help you build a scrollable app, but I want to get the practice in over time so that I can look for different pain points or things that people might need help with and build tutorials and information around that so that my channel can become a source of a place where you can learn. If you're looking to build a recycler view, you're looking to build a scrollable list, you can come by Coding Fanatic and you'll be able to find all the information you need right here. So that's the first thing. The second thing is reading other people's code. Now, in the past, I strictly focused on that last point, but software development is more than just building user interfaces. It's about understanding other people's code and understanding the different concepts that can help drive your app and make it more robust in the long run. But I'll get to that in a second. Right now, I want to focus on reading other people's code. I want to take time to go on GitHub and look at other people's projects or look at what other people have done so that I can broaden my understanding and my perspective of how to build out applications using Kotlin, Jetpack Compose, recycler views, Android Studio, everything. I want to see how other people do it and try to pick up what I can from them. All right, in software development, you're never going to be by yourself. You'll never be a one-man show. Unless you're like the guy who made Cave Story, who built that game from top to bottom all by himself. Then again, it took him a decade, so it's up to you. You want to spend more time writing code, and you want to be by yourself and spend more time, more power to you. But I have found that by working with other people, that I'm able to grow more efficiently. In fact, that was prior to today, that was one of the older pillars for Coding Fanatic, was learning to work with others. Now I'm learning to learn from other people's code. So more than just learning how to build things on your own, also learn from the projects other people have made. If you guys remember a few weeks ago, when I showed how to build a stopwatch and how to build a timer, one of the tutorials that I followed for building a stopwatch had a major bug where every time you press start, the app would increment the timer by 1 second. If I had not gone and researched this tutorial, I would not have seen this. I wouldn't have seen the bug, and I wouldn't have figured out how to debug it and fix that logical error. If I had just sat on my own and done research on how to do everything from scratch, it would have taken more time, more energy, and I wouldn't be able to help out someone who made a small mistake. So more than just even learning for yourself, you can also catch errors and help other people as well. So you're helping yourself and you're helping others, and you're doing it like almost immediately and directly. You get to look at the source code, you get to see how the cake is made and point out any issues that might be there or ask any questions and broaden your own perspective on how to build applications. So number one is practicing on your own. Number two is learning from others. And the last one, Android architecture. Android architecture is something that will really broaden your perspective because you learn how to use all elements of the Android OS to your benefit. Let's say you have a scrollable list, which is our focus here. Let's say you have a list, right? Assume that this list is actually completed. And in the middle of me, let's say it was I had a workout timer that had already started. And the timer is slowly decreasing. And then as it goes down, I get a text from my girlfriend. So I go home, I open up text messages, I read the text or whatever, and then I come back into the app. And all of a sudden, for some reason, the timer is back to, the seek bar is back to full. The time and everything is back to how it started when I first opened the app. So the timer was already counting down, and all of a sudden everything just resets back. Why? Because when I left the app, I put it into on pause. And when I return to the app, it goes into on restart. So by understanding the Android architecture and the life cycle, you can make your app more robust and control how it behaves in these different instances. Let's say there was a timer that was 1 second away from going off, and then I went home and I come back in. Should the timer go off while I'm on the home screen? Or should it wait, stop counting the amount of seconds and stop counting and wait until I go back into the app before it rings the timer? All of this and more can be answered if you have a strong grasp of the architecture. So since the beginning of Coding Fanatic, like I said, I was helping out the new Android developers and showing you guys how I learned as I moved along. But the only thing I focused on was building user interfaces. I didn't learn too much about architecture and backend development, all those and things like that. So by focusing on this, you can make your app more robust and have more control over how it works. Remember, it's more than just a user interface. You have an entire machine in your hand that you can control how it works. It's all up to you, but you have to understand how the architecture comes into play. So the 3 pillars that I'm focusing on moving forward are practicing with Jetpack Compose, reviewing other people's code, and last but not least, learning from the Android architecture, learning about it. So with all that being said, I'm going to take the remaining time that I have tonight, and we're going to take a quick look over at the model view model. So I went on Google. You want to learn about architecture? I'll show you. It's really not. It's pretty simple. I went on Google, I typed in MVVM, and I saw links, many links that popped up. So I'm gonna go with MVC, Geeks for Geeks, Top High, TechTarget.com. All right. Well, just because I know that Ray Wenderlich has a very thorough website, I'm gonna go over here. Actually, I don't need to use I don't even know why these are in a private window. Okay. Learn how and when to use the architecture / design pattern of MVVM in this free chapter from our new book, Design Patterns by Tutorials. Shameless plug well, it's not shameless because it's not my plug, but here's a plug. If you guys are looking to learn more about it, Jay Strong wrote an article on it for raywenderlich.com. All right, so here are a few bullet points on the main information. So I'm just going to skim over it real quick, but let's see. It separates objects into 3 distinct groups. So models hold application data, views display visual elements and controls on screen, and view models transform model information into values that can be displayed on a view. Okay. Let me see here. 20. All right, so we go to 20. Okay, so here we have a diagram that explains a bit more about this model view. What is it? Model view. Model view model design pattern. Okay. So this is a design pattern. So here's the model. Let's zoom this in so you guys can see it too. It's just now realizing that you can't see things as well as I can. All right, so we've got model, the view model, the view, and the view controller. Model, view. So the model is observable. View model configures a view. IB actions, view controller. View controller owns a view. View model callbacks and delegates. Owns and uses. Okay, I'm not really too clear on this. I'll have to read a bit more. Maybe some examples would help. Transform models into another representation for a view. For example, you can use a view model to transform a date into a date formatted string. a decimal into a currency formatted string, or many other useful transformations. This pattern complements MVC especially well. Without view models, you'd likely put model to view transformation code in your view controller. However, view controllers are already doing quite a bit, handling view did load and other view lifecycle events, handling view callbacks via IB actions, and several other tasks as well. Massive view controller. Alright, so it seems like view controllers are the focal point here. Let's check out this playground example. Open this media and design patterns. You open the MVVM page. You'll make a pet view as part of an app that adopts pets. Add the following after code example. Starter directory delete. With class pet. Enum rarity. Let's see if we can find an example on YouTube. Ray Wenderlich's website is pretty good, but I would rather find something that is super beginner friendly for someone who doesn't know anything about Android architecture, like me and most new developers. Hey, that's me. So let's start here. Android architecture for beginners.
Robust and testable Android app. Instead of putting most of the data and logic directly into activities and fragments, as we often do as beginners, we should instead split up the app into different layers, each with specific responsibilities. Some of these classes are provided directly by Google for us through their Jetpack libraries, others come from popular third-party libraries, or are plain Kotlin or Java classes.
Bring this thing back.
The Android Guide to App Architecture is a web page provided by Google that outlines best practices to build a modern, robust and testable Android app. Instead of putting most of the data and logic directly into activities and fragments, as we often do as beginners, we should instead split up the app into different layers, each with specific responsibilities. Some of these classes are provided directly by Google for us through their Jetpack libraries, others come from popular third-party libraries, or are plain Kotlin or Java classes. The activities and fragments should only handle UI logic by displaying data to the user and taking user input, which is then forwarded to the lower layers of the app. You can also say that the activities and fragments should be dumb. The Viewmodel is a Jetpack class that's responsible for holding and preparing the data that's displayed in the user interface, and it also contains logic that is executed in response to user input. It can call into lower layers of the app to store and retrieve data, and unlike activities and fragments, it is not affected by configuration changes, which means that it keeps its data, for example, when the device is rotated. Because the Viewmodel outlives the activity, it must never keep a reference to the activity, because this would cause a memory leak. Instead, the Viewmodel exposes.
All right, so I wanna take a second to let me play that one again. I thought that was really important.
And unlike activities and fragments, it is not affected by configuration changes, which means that it keeps its data, for example, when the device is rotated.
All right, so if you think about an app like something like, I don't know, like your bank app. Let's say you're with, I don't know, Cherry Chase Bank, and you're using your app to input your information, and you do something like turn the phone sideways. You want it to retain all the fields that you'd already entered while the phone changes orientation. So let's look at my app, for instance, that I have, and see what happens when I change the orientation here. I suppose. All right, so let's say we turn the phone to the left. Okay. I don't know if this is supposed to change as well. Is it supposed to change? It's definitely doing something. All right, that might not be the best example. I think that it's Android Studio is having a hard time. Yeah, I don't know. But pretty much, if you turned your phone sideways and you were entering, even if you look at something like the search bar here, if you typed in like face B and then you turn your phone sideways, you want it to retain you want the, this is really cool. I am not even trying to really do this right now. I was trying to make a point. Okay, let's say you, okay, sure. Let's say you do this with the phone. There we go. You're typing and then you turn the phone sideways like this, or the phone. Yeah, you hold it like this. So now what you want is for the search bar to appear up here with all the icons appearing down at the bottom, because in the original orientation, they were all set up like this, where the search bar is at the top and the icons are at the bottom. And you want it to where if you turn it sideways, it does the same thing. So that is the idea behind, or you want it to either stay static where the screen remains like this, or if you turn it sideways, everything else changes its alignment. So that's the idea behind messing with or setting up. Once you have an understanding of the architecture, then you can configure things like this within your apps. And more than just building out a user interface, you can control even what happens to the user interface when the phone changes orientation. All right, so let's get back to it.
Data, and unlike activities and fragments, it is not affected by configuration changes, which means that it keeps its data, for example, when the device is rotated. Because the view model outlives the activity, it must never keep a reference to the activity, because this would cause a memory leak. Instead, the view model exposes observable data holders like live data or Kotlin flow that can be monitored by the UI layer. An app usually gets its data either from a local database or from a remote API, from the internet in other words. Often the data coming from the internet is cached locally by storing it in the database. This way the app can show data faster and even when there is no internet connection. The repository is a plain
Play that part again. Let me see this.
or Kotlin flow that can be monitored by the UI layer. An app usually gets its data either from a local database or from a remote API, from the internet in other words. Often the data coming from the internet is cached locally by storing it in the database. This way the app can show data faster and even when there is no internet connection.
So for this specific example, in the excuse me, for the Salesman's Travel app, my first app that I ever published, I set up the addresses. Actually, no, not for that one. For the Daily Inspiration app that I set up, that was my second app, the one I did before the Super Timer. I set up the app to pull quotes from a Firebase real-time database. The problem was that if the phone were disconnected from the internet, it could not talk to the server because the phone is offline, and so no quotes would appear because it can't actually pull them in. But using app architecture, you can configure your app to cache the information in your phone's database so that if you get disconnected from the internet, you can still display the information. So, I mean, it's the same thing with a Netflix app. If you go on Netflix and your phone is offline, you can still go in the app and interact with it. you just can't watch anything or search anything because there's no way to query you can't query anything because the bone is offline.
The repository is a plain Kotlin or Java class that decides when to fetch data from which data source and when to refresh the offline cache. This way, all this logic is hidden from our view models and we keep them small and maintainable. To keep the different layers of the app decoupled, we use the technique of dependency injection, which means that no class instantiates the classes it depends on. The view model does not instantiate the repository, and the repository does not instantiate the database or the network client it needs. Instead, these dependencies are passed to these classes through their constructors. A library like Dagger-Hilt makes this process easier by managing the dependencies for us. With the structure, each layer of the app can be tested in isolation because dependencies can be swapped out for fake implementations, and when we need to make changes to a layer, we can do that without having to also change the other layers.
Cool. Thanks, Coding and Flow. So using app architecture, you can divide the app into...
This way,
using app architecture, you can split your app into multiple layers. Let me find one where he's actually showing it.
And also the interface.
He goes through one by one.
Which is then forwarded to...
Alright, so you have, based on this, there are 3 layers total. You have the activity or fragment, which is the UI.
Libraries, or are plain Kotlin or Java classes, playing data to the user and taking user input, which is then forwarded to the lower layers of the app. You can also say that the activities and fragments should be dumb. The Viewmodel is a Jetpack class that's responsible for holding and preparing the data that's displayed in the user interface.
Okay, so the first layer is the activity or fragment, which displays information and obtains input. The second layer is the view model, which stores the data that's used to display in the activity or fragment.
Activities and fragments should be dumb. The Viewmodel is a Jetpack class that's responsible for holding and preparing the data that's displayed in the user interface. And it also contains logic that is executed in response to user input. It can call into lower layers of the app to store and retrieve data, and unlike activities and fragments, it is not affected by configuration changes, which means that it keeps its data, for example, when the device is rotated. Because the...
Okay, so this prepares the information that's displayed to the user. So if you change the device orientation and you have your app coded the way that I've been doing it this whole time, where everything is all in one activity, those device configuration changes can effectively it can affect your app's UI, and that in turn might interfere with the data itself. So like the example I gave where you're filling out fields in your banking app and then you turn the app turn your phone sideways, all of a sudden it all just disappears, and that's because you don't have a view model that's configured to hold that data for you. Everything is set in the activity. Then if something goes wrong in the activity, that can affect the data. But by compartmentalizing everything into different spaces, you can ensure that your app functions as expected, regardless of the change to configuration.
Viewmodel outlives the activity. It must never keep a reference to the activity, because this would cause a memory leak. Instead, the Viewmodel exposes observable data holders like live data or Kotlin Flow that can be monitored by the UI layer. An app usually gets its data either can be processed activity. Viewmodel outlives the activity. It must never keep a reference to the activity, because this would cause a memory leak. Instead, the Viewmodel exposes observable data holders like live data or Kotlin Flow that can be monitored by the UI layer. An app usually gets its data either from a local database or from a remote API, from the internet in other words. Often the data coming from the internet is cached locally by storing it in the database. This way the app can show data faster and even when there is no internet connection. The repository is a plain Kotlin or Java class that decides when to fetch data from which data source and when to refresh the offline cache. This way all this logic is hidden from our view models and we keep them small and maintainable.
Okay, so this going back to the Daily Inspiration app, if I'd used a repository, then I would have something that can control the data that is held by the view model and displayed in the activity. If there's a local cache, cool, then the repository can pull from that to display the quotes. But if there's a remote API, once there's a remote API, then you can pull the data over the network. But let's say your device goes offline, or your device goes offline while you're using the app, then there's already a local database or model that the repository can pull from. So you've got the activity, which displays everything and obtains input. You have the view model, which takes the data that is displayed or stored and can manipulate it regardless of any configuration changes to the activity. And you have the repository, which can pull and post information to and from a remote data source using API or an API call or a model using a local cache. And all three of these layers come together to control how your app works. So even with when we go back to the super timer, I can already think of different ways that the app could that I could build on what I have here, by instead of hard coding the each text view and trying to use values like I have here to track the time remaining and reps remaining, the view model could do all of this. And all I really need to do is just have a text view button, text view, and seek bar, and all of the data or all the information that affects each of these views would be stored in a view model. And if I keep the information in a local cache, then I can pull it in using the repository and then have it managed by the view model. And if I want to create an online database, or a remote data source like they have here, then I can do that too. And the repository will make an API call that pulls that information into the view model, and then the view model will display it via the activity.
To keep the different layers of the app decoupled, we use the technique of dependency injection, which means that no class instantiates the classes it depends on. The view model does not instantiate the repository, and the repository does not instantiate the database or the network client it needs. Instead, these dependencies are passed to these classes through their constructors. A library like Dagger Hilt makes this process easier by managing the dependencies for us. With the structure, each layer of the app can be tested in isolation because dependencies can be swapped out for fake implementations, and when we need to make changes to a layer, we can do that without having to also change the other layers.
Cool. Well, I'm not too familiar with app testing, but I'm sure I will be once I start setting up an architecture for my app, because by using an app architecture and dividing your app into different layers, then you can test each layer individually, like you said. As far as I know, testing, I've only done the actual manual testing where I take the phone or take the device and just try to mess around and see if I can get it to break. The application that if we want to, you know what? Actually, it's the new window. This window. Oops. Let me see if I can open this thing up. No, we are almost. You know, how about this? No need to open it up. Let's say, pretend this is the timer app that I fixed recently. Every time I hit start, if I hit start, the time starts and the time remaining decreases by 1 second. If I pause, it pauses. And if I start again, it decreases again to 7. So if I sit here and hammer the button, then the time remaining will continue to decrease. By using an application architecture, you can test the amount of time remaining is stored inside the view model. So I don't have to deal with the activity to learn to figure out what the issue is. If I want to isolate the issue, then I can go to that layer of the application and test there instead. So I can look at the view model and see what all is going on with that. But the UI itself is separate. I don't have to even think about that. Okay. So the main thing I got from this is that using app architecture allows you to divide your app into multiple layers, use multiple layers, and it's easier to test and configure the different components of your app. Okay. With all that being said, everyone, it is about that time. So thank you all again for tuning in to the Android Architect live stream. I'm your host, Richard. And again, here at Coding Fanatic, I will teach Android developers how to build scrollable apps using Jetpack Compose. My main pillars I'll focus on are Android architectures, practicing building apps on your own, and of course reviewing other people's codes so you can expand your horizons. These are the pillars I believe are the most pertinent to learning how to build these apps, and that's what I'm going to focus on here. I want to learn as much as I can and then relay my lessons onto you. And if that sounds like content that you're interested in, join the mailing list, subscribe to me on social media, follow me there, and all that good stuff. So for anyone who has experience with Jetpack Compose, you tell me, well, what would you focus on if you wanted to start over? If you had to start over, what would you focus on most for building, or if you wanted to build scrollable apps using Jetpack Compose, what would you go to first and where would you focus? Let me know in the comments below, or you can message me on social media and all of that. With all that being said, again, guys, I'm your host, Richard, signing out, and I thank you all again for tuning in, and I will see you all on the next one. Peace.